Okay, now we're going to determine the constraints of a quadratic function. So constraints mean that if there were no constraints, this u would just keep going on and on and on for forever. But we can see that this doesn't happen. It doesn't keep going down. It doesn't go this direction. So let's identify these constraints, because the action is only happening inside of what we call the constraints. So the first thing I like to do is identify the domain. So the domain here is, it starts here. You can even write this as a point. It ends at this point. It starts here. This point is 0, 26. And this is 3.50. So it starts here on the x. This is the domain of 0. Okay, it doesn't start at 26. The x value of that 26 is 0. So 0, then we always put a less than or equal to. And then my x here, you might see it written as an x because it's on the x-axis, or you might see, since this was given a name time, you might see t. We're going to write t. So the time is between 0 and, we write less than or equal to, our highest value, 3.5. So the constraint for our domain is between 0 and 3.5. The range, which is our y values, and we have height here, so you can either, on the y-axis, you can write an h, or you can write y. We're going to put h is, we have a 0 here for our y, and I know it's all the way on the right, but our lowest point on the y-axis is 0. It's less than or equal to. And our highest point, I would actually be wrong if we used this 0, 26. What is our highest point? Right up here. That's a 30. So be careful with the quadratics. It's not as simple. It's not like lines where you have an actual beginning and end and doesn't curve. So here we have the highest point is 30, and you 100% will see an option that gives you the lowest point as being, or the highest point as being 26. But a curve is going to go up a little bit further and reach a peak value, the max or the min. Okay. So final answer: the domain is between 0 and 3.5. The range is between 0 and 30.